Perhaps you've seen videos of how the planets of the solar system move through the universe in this cool helix. But not only are these misleading, Earth's real motion, your real motion through the universe, is way more complicated and way more interesting. One thing is inaccurate about this depiction, and that's the idea that the planets are orbiting the Sun while the Sun is fixed relative to the planets. The planets tug on the Sun just as it tugs on the planets, causing the Sun to move. The best reference frame to describe the motions within the solar system is that of the barycenter, the center of mass of all of the objects in the solar system. This is the real point that everything in the solar system is orbiting. From the reference frame of the barycenter, the Sun executes this complex pirouette, mostly in response to the outweighted gravitational pulls of Jupiter and Saturn. The solar system's barycenter is sometimes beneath the Sun's surface, but when the two giant planets are even vaguely lined up, it can be quite a way outside the Sun. We're moving up and out of the galactic disk at around 7 kilometers per second. We are currently a few dozen light years above the middle of the disk, although it's actually hard to know where the center of the galactic disk is. We're not in danger of escaping the galaxy. With more matter below us than above us, the disk's gravity is slowing our upwards motion. In a few million years, we'll have clawed our way out to around 300 light years above the disk's center before our upwards motion slows to a halt and we begin to fall back in. We'll plummet through the disk, overshoot, and pop out through the other side. We execute one of these graceful leaps roughly once every 60 million years, so a few times per galactic orbit. This vertical oscillation is more than just a curiosity. Some astronomers think it could be directly tied to mass extinctions on the Earth. You know, the dinosaurs went extinct 60 million years ago. The center of the disk is a more dangerous place for the solar system due to the higher density of stars. It puts us at a bigger risk of a nearby supernova or close encounters with other massive objects that could destabilize debris in the outer solar system that could then impact the Earth. But that's a story for another time. Okay, just one more bone to pick about this so-called vortex motion. Currently, the ecliptic is almost face-on compared to the Sun's orbital motion, so the corkscrew is valid. But due to conservation of angular momentum, the plane of the solar system won't turn with the Sun's orbit. After a quarter of a galactic orbit, the ecliptic plane will be edge-on. The solar system will be like a great wheel rolling in the direction of the Sun's orbit. We now have a picture of how the solar system really moves through the galaxy. But how do we move through the universe as a whole? The Milky Way is pulled by the gravitational fields of the masses around it. We're racing towards the Andromeda Galaxy at a couple of hundred kilometers per second, while our entire local group, Andromeda, the Milky Way, and the other little galaxies around us, are being pulled at several hundred kilometers per second towards a mysterious overdensity in the clustering of galaxies called the Great Attractor.